Today I'm going to make a video about why I think unique pointer considered harmful. So you can just search the video. Here's this video. This guy is preventing resource leak with unique. Look at what he did. Okay, let's look at what he did. So
use smart.
what he did is using a unique pointer void to function the echo type. That tells you that unique pointer leads to brain death. People just abuse unique pointer. Unique pointer just completely abused nowadays. No. He also did that to Firestar. To function. Oh, this is dumbass. This is complete dumbass, right? It's completely retarded, and it's retarded. I mean, you're not passing by value, you're passing by reference. So, okay. So there's some reasons. I'll just make a summarize. First, unique pointer lead to all abuse. If you want to use polymorphism, just use this type erasure instead. Let me show you the assembly. Even the assembly is not short. You can see with unique pointer, you have one more instruction, but using this type erasure with the shape observer stuff, you only have two instructions. So you save one instruction. And the first instruction is actually moving from memory. It is an extremely costly operation because load data from memory is expensive. And you have another dependency here because you first load from memory, then you load it again. Now here we don't have any memory loading. We just directly jump to the instruction. We have a file call. That's it. I have tailcall optimization. So if you want to use polymorphism, use type erasure instead. The same reason is that unique pointer is not constexpr. Even using muting for managing memory is completely useless because it's not constexpr. Now, because of that, we can see unique pointer is not zero overhead, right? You see this one is more instruction here. And using unique pointer, you know what I see these people, they're wrapping resources with unique pointer is completely painful. And you only solve one problem, you don't solve all the problems here. I'll give you an example. So here using unique pointer, what you're gonna do is that if you call fprintf, you need to do this, okay? You need to check error code of fprintf. That's what the standard is requiring you to do. And even so, I think that the code is still wrong because fclose does not allow to pass new pattern. It just do not allow that. You're not allowed to pass new pattern here, and this code is completely wrong. So what you're going to do is you need to check fprintf error code smaller than 0. You need to do it every time. Any C function call, you must check check exceptions. Like the code is doing here, is completely false. Okay. Don't do this. Just please do not use unique pointer to bound to function, whatever nonsense. It's complete nonsense. And with to function, you're probably even going to exception against thrown. That is going to further bloat your binary side. So do not use unique pointer. Okay. Just write a class. Don't be lazy. I think the lesson we need to learn is that don't be lazy. Write it. Okay. You see, the unique pointer, you can even check the error codes systematically. Okay, we have you can have the REI systematically instead of just tweak it around. Don't do this. Don't use the unique pointer. It's just harmful. Just through exception with it. Okay. yeah, we can see you don't solve any problem because this code is much shorter now. Okay. Okay. We can do this. Let's see assembly what assembly generates. Okay. Printf. I think if I call more enough, the compiler should merge code. It should merge all this stuff together. It can become a real function. Alright, the compiler feels that it doesn't have the need to do this. Oh. So now if you're using the test trace, you have to manually unwind everything. You have to manually do this. Okay. If you don't, you must check error codes of printf. I think the problem with Unicode is that you only solve one problem. You don't solve all the problems, right? You don't check error code of fopen. You do not check the error code of printf. With if you write a real class, you can do this. You can just check error codes and with it. And finally, what I want to describe is that the size of it, of the file. For example, if you want to make your stool file using Unicode, you want the Unicode, use Unicode, you want to ensure that you want to ensure the deleter. You want to do this. Okay, let's just do it. So what you want is using an importer p file dicot type close. Oh, do you see what's wrong here? Yeah, no. Yeah. You can see here the unique part of file, dicot type file, you have the file size is 16, which is larger than file star, right? So what you can do with it? What people would do is using a lambda. I have a lambda. I have a lambda, right? I have a lambda. And here I have a stool file, fp. I check fp, then I call it close. Correct and consecutive. Okay, so it looks like, okay, it looks like, so here it looks like we cannot get rid of a unique purpose, right? It sounds like the case. So we have a dicot type lambda. Now it will say, yeah. However, the problem with this approach is that when you pass it into a template type, template type. Putting it, we'll put it here. We define a unique pattern. We mark as GNU knowing line, so we can see the cost. GNU knowing line. So f UP. Okay. I ask you to not use my function. Why? It looks like it gets right. So I can do what I can do is using another function to and internally it's fire slash p, so it will get eliminated. And action function, we call that as a function to g.get, for example. Yeah. Then you probably have another function that also uses another lambda2, which is doing exactly the same thing. Lambda2, okay. Then you use this lambda2 upt2. You call that function, you call this function. Now we can see even the function is doing exactly the same thing. Okay, they're doing exactly the same thing. They generate twice as much as code. You can see there's two functions here. Here are two functions here. So if your function body is large enough, let's just do something. For example, I think a fair example is putting a school vector and sort it. Or put a span, whatever. Put a vector, okay? Let's just put a vector. So we have a vector size b. Pretty easy, okay? Now we sort that vector. Now, so the compiler cannot optimize the thing. Now you can see the compiler is start to blow its binary size. We have a main function. Please do not inline it. Okay. Please do not just no inline. Okay. I want to see through the cost. It's just GNU no inline. GNU no inline equals GNU no inline. Now you see here you have two functions, okay, for doing exactly the same thing. I'm just putting a sort here. It generates twice as much as code. It generates too many code because it just generates too much code of it. All right. Now because for the compiler, it thinks that they're two different types. Even your lambda body are exactly the same. There are two lambdas now. So unique pattern will lead to binary bloat. If you're using template with the templates, it blows your binary size. Okay, it blows your binary size. So that's unfortunate. We have lambda 3. We do it again. You can see unique pattern has too many overhead of it. You cannot get rid of it. Okay. Instead of just one function call. Okay, let's just remove all the bullshit with our C file to see what C file would do. Okay. By the way, C file we probably also need another Okay, we just put it empty. We don't have to get method. So you C file. What we do is C file. Okay, C file. Then we call F. Let's see what happens with C file. If we try to do it again. Now we don't even need to mark it as no inline anymore. I think the compiler won't inline it. See the summary here? Okay. I think you continue put C file. I think we will reach a point the compiler won't optimize it. We'll do this. I don't believe compiler will always do this. Then what about GCC? Yeah. See the code here? Call. Because you have the type now. The type is deterministic. Even using a different translation unit, they will still use the same function. We will try another translation unit. So using unique pointer, you're probably using it with lambda. If you're using it with lambda, it incurs another cost of it. So please do not use lambda. Lambda considered harmful. Do not use lambda in C++. Okay. So because the unique pointer just lead to laziness and unacceptable overhead if you're not careful enough. Probably the only thing you can do is using it as a scoped pattern and never pass it into an interface. But it doesn't work, right? You can see that in the previous example, it blows binary sign. This stuff blows binary sign with unique pattern. Because for the compiler, it thinks that they're separate functions, they're separate types. They don't think even your function body are exactly the same. They don't think, oh, you're writing the same function. So you can see Unicode incurs too much overhead in it, and the size of it. And when you try to get rid of it, it still breaks down. Just too many overhead with it. So the lesson we need to learn is that we need to write a real class, not using Unipointer. Unipointer is harmful, and never wrapping C API with Unipointer. Unipointer only leads to laziness. It solves one problem, but there are still problems Unipointer does not solve. Okay. So of course, the major problem, finally I would say, the major problem is because of semantics. I want a shape, right? I want a shape. I don't want to add a unique pattern shape. So if someone is telling you that it's a shape pattern, okay, what does that mean? A pointer to a shape? What does that mean? I want a shape. I don't want a pointer to a shape, right? That's the fundamental problem with it. Is that it lacks the semantics. For example, here I have a C file. I know exactly what a C file is, but if you have a unique pattern file, F close, what does that mean? Everyone can understand what is C file. C file is the file type of C, right? That's a file style, the C file. But no one is going to understand what is a unique pattern here. I just try to explain people who never use C++. They never understand what is unique pattern, F file, F diagonal type, F close, whatever nonsense. And using lambda stuff doesn't work either. And you can see you already did a huge amount of work here. If you can do this, just write a real class. Don't be lazy. I think the lesson we need to learn is that don't be lazy. When you see a C resource, please wrap it manually. Do not use unique pattern to wrap it. That is an abuse for me. Because with C type, you first need to check exceptions. You don't check exceptions when you're using these types. Using unique pattern, you never check exceptions, which means You just solve one problem. You just solve memory leaks problem, but you're not solving errors getting, the problem, the error code getting ignored. Okay, this usually C API will return error code. Using it for parsing object or programming interface, you don't need object already programming. Just use type erasure. Okay, so constexpr is binary bloat. Okay, completely nonsense. Uniprot is completely altered track.